Hello, and welcome to the Bleed Air System lesson in the PMDG 737 Next Generation Groundwork from Angle of Attack. This lesson will cover the following topics: bleed air description, application, and sources, pneumatic manifold, engine-supplied bleed air, APU-supplied bleed air, and ground air connection. Bleed air system controls and cockpit indications will be discussed progressively as we move along in this lesson. Bleed air is compressed, highly pressurized air that is very hot. It's used to power certain aircraft systems that require energy from pressurized air as opposed to fuel or electricity. Many different aircraft types with different engines rely on bleed air for their operation, from turbopropellers all the way to turbofans. The temperature and pressure of bleed air varies a lot depending on where it's extracted from. On average, it may be pressurized to 40 psi and as hot as 250 degrees Celsius. Bleed air may also be referred to as pneumatic power. Specifically on the 737 NG, bleed air is used to power the following aircraft systems: Engine 1 and 2 start systems, air conditioning and cabin pressurization, Engine 1 and 2 cowl anti-ice systems, wing anti-ice systems, water tank pressurization system, hydraulic system A and B reservoir pressurization system, and a few other minor elements also rely on bleed air, such as air temperature probe aspiration systems or nitrogen gas generation, among others. Engine start systems rely on bleed air to turn the high-pressure N2 rotor when the engine start switch has been placed in the ground position. Engine and wing anti-ice systems also rely on bleed air to prevent icing formation and buildup, which could lead to rough aerodynamic surfaces and eventually loss of lift. The air conditioning and cabin pressurization systems rely on bleed air to supply and recirculate air through the cabin. All these systems are covered in the engines, ice protection, and air conditioning lessons, respectively. As we can see, there are many aircraft systems that rely on bleed air for their operation. Let's discuss where all this power is obtained from. Pneumatic power may be provided by any of the following sources: Engine 1 bleed air system, Engine 2 bleed air system, Auxiliary Power Unit or APU bleed air system, Ground Power Unit GPU air connection. Engines are the primary source of bleed air on the 737 NGX. Bleed air from all four sources is ducted into a pneumatic manifold system that collects all this air and essentially acts as a giant pool. Valves on the pneumatic manifold control bleed air flow into the respective aircraft systems. These valves are operated individually by each aircraft system. For example, when the wing anti-ice switch is placed in the on position, the wing anti-ice valve opens and air from the pneumatic manifold starts flowing into the anti-ice system. In order to provide system redundancy against any possible pneumatic duct pressure failure, a bleed air isolation valve divides the pneumatic manifold into a left and a right side. An isolation valve switch in the forward overhead panel controls the manifold isolation valve and has three positions: open. Right and left sides of the bleed air manifold are connected. Auto. The valve is opened and closed according to specific aircraft operations. Close. Right and left sides of the bleed air manifold are isolated from each other. The following systems and interfaces are linked to the right side of the pneumatic manifold: Engine 2 bleed air system, Engine 2 start system, ground pneumatic connector, right air conditioning system, right wing anti-ice system, hydraulic systems B and standby reservoir pressurization, and isolation valve. Similarly, the left side of the manifold relates to the following systems with bleed air: Engine 1 bleed air system, Engine 1 start system, APU bleed air system, left air conditioning system, left wing anti-ice system, hydraulic system A reservoir pressurization, total air temperature TAT probe, water pressurization, and isolation valve. It's not necessary to memorize what system is associated to what side of the pneumatic manifold. To summarize the important bits, we must emphasize that the ground pneumatic power connector is linked to the right side, and that the APU bleed system is linked to the left side of the pneumatic manifold. The Engine 1 and 2 bleed air systems are associated to the left and right sides, respectively. There are two duct pressure transmitters, one for the left side of the pneumatic manifold and another for the right side. Each transmitter provides indications to duct pressure pointers in the forward overhead panel. Differences between both pointers are permissible as long as there is sufficient air for cabin pressurization. The minimum value is 18 psi. Moving on, we'll now talk about each individual source of bleed air on the 737NG. Let's start with Engine 1 and 2 supplied bleed air. The engine bleed air system supplies pressurized and regulated bleed air from the 737NGX engines into the pneumatic manifold. Even though engines are very thoroughly discussed in their related lesson, we're going to briefly mention a few general aspects of how an engine works. The fan sucks outside air into the engine. After that, the air passes through a series of low and high pressure compressors that increase its temperature and pressure. Following compression, air is mixed with fuel and ignited in order to finally pass through a series of turbines that turn the respective shafts in the engine and thus turn the fan, causing a forward pushing force or thrust. A part of the air in the compressor section is extracted and ducted out of the engine. This is high pressure, high temperature bleed air. Technically, bleed air is extracted from the 5th and 9th stages of the engine high pressure compressors. In some engine scenarios, such as when there's a high pneumatic demand from the aircraft systems and the engine is running at idle power, bleed air from the 5th stage is not enough to supply the required demand. In this case, the pneumatic system commands bleed air extraction from the 9th stage of compression automatically by means of a high stage valve. Each stage of compression has a check valve that controls the flow of air between the compressors and the engine bleed air manifold. Just like the pneumatic manifold in the 737NG fuselage, there is also an engine bleed air manifold that essentially is a pool of bleed air collected from both compression stages. The 5th stage check valve prevents 9th stage bleed air from entering into the 5th stage bleed air port. There is a bleed air pressure regulator and shutoff valve, which we'll call PERSOV, that is controlled by a bleed air regulator, or bar. The PERSOV essentially performs the following functions: bleed air pressure regulation to a nominal value of 42 psi, bleed air temperature limitation to about 235 degrees Celsius by means of a thermostat and pre-cooler, and bleed air shutoff. The engine bleed air switches are located in the forward overhead panel and have two positions. On opens the related engine bleed air shutoff valve when engines are running, and off closes the related engine bleed air shutoff valve. Bleed air temperature is cooled in a cross-flow heat exchanger referred to as the pre-cooler. Ideal bleed air temperature should be between 199 degrees Celsius and 229 degrees Celsius, and it is achieved by exchanging heat between cool engine fan air and bleed air. An over-temperature mechanism protects the pneumatic manifold from receiving bleed air that is too hot. The threshold temperature is 254 degrees Celsius, after which, if an overheat condition is detected, the bleed air shutoff valve is closed and the cockpit bleed trip off light comes on.